Welcome again to our course on biodesign, strategies for innovation and design of bioengineering. Today we're going to talk about final concept selection. This is going to be a really interesting topic for many medical device innovators because it's probably one of the most pressing subjects that everybody has when thinking about innovation. How do I choose the best concept? How do I choose the best way of tackling a problem? How do I do not take a look at the other concepts that I have already figured out and choose for one that is going to be the best, most outstanding way of solving a problem? So in order to do that, there is this class, and let's start. So the objectives for this class specifically are to understand how to use the data that you have already gathered throughout this point in your innovation process and to effectively evaluate all the solution concepts that you have come up about. I also want you to recognize how to apply an approach and a specific quantitative approach such as the Pugh method to develop a concept selection matrix to decide which one is going to be your final concept to work on. Okay, so what is the Pugh concept? Well, Stuart Pugh created this decision matrix method, which is basically a quantitative technique used to rank multidimensional options from an option set. It is frequently used, or it has frequently been used in the engineering field for making sound design decisions. The most interesting part about the Pugh concept selection method is that it uses weights in every single characteristic that you want to evaluate in order to make a weighting system that at the end creates scores for you to confirm the concepts that you have to choose. In this sense, there are four different stages that are going to need to be achieved in any Pugh concept selection method to work in the biodesign innovation process, and these are: first, to identify the user and the design requirements, so which ones are the basic absolute criteria that your product has to meet and which ones are desired. You have to explain them in a very synthetic, sound way so that you have a very compelling, descriptive, small list of the most critical things that your device has to work. That's gonna function as an input for your matrix, which is gonna have those characteristics in one side, and each characteristic is gonna be assigned with a weight. A weight that is going to be determined by the user and by these design requirements, which one is more important, which one is less important. And as you're going to see, even though there are in all designs there are critical characteristics that must be met in order for the user to use it, of course there are going to be some that are even more critical than others, and that's why the weighting is so important. After having identified your requirements and having weighting them, you confirm your concepts, so which solution options you have already come about, and you put those in the other part of the matrix so that you have all your characteristics with certain weights and all the different options for concepts that you have in the other part of the graph of the matrix. In that way you create this matrix in which you can evaluate each and every single concept with each and every single characteristic that it has, or that it has to have. At the end, all these three things are going to be put as an input for, at the end of the process, assign scores and rank all your concepts depending on how well every single concept meets the design requirements that you have already explicitly set and weighed in your matrix. So in terms of other ways to select your concepts, there are mind maps. And mind mapping concepts can be a tricky business because probably it starts with a very, with your need statement and a very general solution of how you want to work around what are the strict absolute design requirements that you want to meet. In this case, for example, a certain cardiovascular cardiopathy related to strokes and atrial fibrillation probably. What you're going to do is that you're going to have concepts and you want to map them on how they are trying to solve the problem that you're referring to from the different ways it acts. So in this example, for instance, you have a problem and every single different solution, concept of solution is going to attack the problem from different anatomical places, let's say the aorta or the atrium, or through a chemical based mechanism or a mechanical mechanism. Whatever it is, basically the idea of mind mapping concepts is that you have a very clear idea on which concepts can be clustered in a single type of way of solving a problem and which ones cannot. And with this idea, you can map them and you can visually assess which spaces have you already fulfilled with many ideas and which ones you have not. This is an input for you to see which different solutions have already met a lot of design requirements, but also to know in which space you want to tackle the problem, because as in every problem there is going to be one or some root causes which are the ones that ultimately you want to tackle. And if you can assess which of your concepts is tackling the root cause of a problem, that's probably a good way to start also from a scoring system, and it's probably a good way to go by in selecting your final concepts. But coming back to a scoring system, to the Pugh method, what you can see is that the scoring system might look just like the thing that I'm showing to you right now. It's basically a matrix as I'm describing, and in one side of the matrix you describe all your absolute criteria that must be met, your design requirements, and you basically put a weight on them. A good rule of thumb in the biodesign process, which has been used by Stanford and by JHUCBID, is to assign a weight that range from 1 to 3 or 1 to 5. In terms of the importance, so the larger the weight, the more important the characteristic is to be met. At the other side of the table, and probably defining the columns, what you're going to have is your different solution concepts. And so the idea here is that when you create these scores and when you are evaluating your different concepts, you have everybody in your team and all the stakeholders that you're inviting to score the different solution concepts are aware of all the nuances and all the different characteristics that each and every single concept has. So everybody in the team that is scoring the different treatment options that you're creating must know exactly how they work and why are they important, and all of them have to have the same information, which should be extensive enough for everybody to make an informed decision on what is the best concept solution for that specific requirement. From that, you can assign any type of different scoring systems. You can choose from negative to positive numbers. You can choose from 0 to 5. You can choose from whatever scoring system you want, as long as you define it. What does a 0 mean? What does a -1 mean? What does a 6 mean? And as long as you have that clear, you can use whatever type of method. Of course, there are best practices as we are showing here. So scoring method that has negative and positive numbers is probably going to acknowledge the fact that there are solutions that not only are neutral but detrimental in a certain design requirement, and that's what a negative number in the scoring system gives you. Nonetheless, again, you can use whatever system is best to you and the one that makes most sense for you in your innovation process. With this in mind, is just to conclude this class, I just want to say that a final concept selection is it tends to be thought as an art, but probably most of the best design concepts out there have been selected through a quantitative replicable system such as the Pugh method. So a safe bet for you in early stage innovation process, and probably for the rest of your life in terms of these medical projects for you, is to acquire a system that you become comfortable using, such as this one, but always the same, so that you have a parameter to compare them against previous events of scoring. And with this, we have concluded our class on final concept selection. For more information, please take a look at the final concept selection chapter on our biodesign book from Seniors and Stanford Biodesign. My name is Luis Soengsen, and thank you for watching.